Hi everyone. Today we are going to explore an interesting problem called rooting oranges, explained using a story-based approach in data structures and algorithms. This problem helps us understand how time, spread and connectivity work together in a grid environment. Through this presentation, we will see how a real-life situation can be efficiently solved using a smart algorithmic approach. And coming to the problem statement or the understanding, let us first understand the problem clearly. Here we consider a grid village filled with oranges. Some are fresh and some are rot and some spaces are empty. The important role is every day a rotten orange spreads its infection to the adjacent fresh oranges up, down, left and right. This slide visually represents how the infection spreads step by step, making the grid dynamic and time independent. The core challenge is now the main question of the problem. The core challenge is to find how many days will take for all oranges to become rotten. If every fresh orange can be reached by the infection, we calculated the total time required. But if even one orange remains unreachable, then result is -1, meaning it is impossible to rot all oranges. This question focuses us to think about efficient transversal, simultaneous spreading and optimal use of timing. And upcoming slides will continue by Bhartwas.
Understanding the brute force simulation. Brute force solves the problem by simulating the time minute by minute, just like the problem statement. The grid represents oranges, 0 represents empty cell, 1 represents fresh orange, 2 represents rotten orange. Every minute, rotten oranges infect adjacent fresh ones. In brute force, we scan the entire grid repeatedly, identify fresh oranges that will rot in the current minute, update them after the scan to avoid instant chain reactions. Time increases only when at least one orange rots. It directly imitates real world spreading, simple, intuitive, and easy to reason about. Minute by minute flow. In minute 0, one rotten orange exists. In minute 1, adjacent fresh orange becomes rotten. In minute 2, newly rotten oranges infect their neighbors. This process repeats until all oranges rot. That returns the time. If no new rotting occurs, it returns -1. This important detail is going to be newly rotten oranges do not infect others in the same minute. This preserves the correct time tracking. The teaching point is each minute is equal to full grid scan plus controlled update. Let's discuss about time and space complexities. The time complexity is equal to the whole grid size. That implies row into column, R into C. Worst case scenario, scan entire grid for every minute. That means we go of R into C whole square. Very slow for large inputs. And space complexity. Extra list to track oranges that will rot. We go of R into C in the worst case. This key limitation is going to be repeated unnecessary scans, poor scalability. In competitive coding, this leads to time limit exceeded. Conclusion for brute force. Brute force is conceptually strong, but performance is weak. It sets the foundations for the optimal BFS solution. Now we are going to discuss about the optimal multi-source BFS approach. This approach visits each cell only once. No repetition, no wasted effort. That's why the solution runs efficiently in O of R into C time, making it scalable even for large grids. A brute force approach would repeatedly scan the entire grid, wasting time and resources, while VFS avoids this by working only where change is happening. At minute 0, only a few oranges are rotted. At minute 1, their neighbors turn rotten. With each minute, The influence grows until either all oranges are infected or the spread stops. Let's discuss about edge cases. If all oranges are already rotten, time needed is zero. If some fresh oranges remain unreachable, the system clearly tells us it's impossible. Let's discuss about the final insight. This problem teaches us more than coding. It shows how the right data structure can transform a complex situation into a clean and elegant solution. And the conclusion. To conclude, the rotting oranges problem is a perfect blend of logic, efficiency, and real world thinking. BFS doesn't just solve the problem, it tells us a story of time, spread, and control. Thank you for your valuable time. I hope this presentation helped you see how simple ideas can solve powerful problems. I'm happy to answer your questions.